Assalamualaikum. I'm Nafisa Mustari, ID 19101086. I will be talking about our paper technique to estimate the status of legal proceeding considering sequential text data. So first of all, if I am going to talk about the type of challenges we face, is that there are very less researches done on the judicial cases using NLP application software and machine learning techniques. So one of the author from our citation branding et al. Said that involvement of technology in legal argument and its solution has been aim of computer research and since inception. However, legal computer systems were never widely used and computer science and law remain a special field of study with minimal application. So when we searched for the paper on the context of Bangladesh, we found a very less paper, almost no paper in this site. So it was difficult for us to get data set sources. So we started studying on that section, and we found out that there is available cases of Bangladesh Supreme Court with their decisions. So we used this source of data as our data set, and the research objective of our paper is that to find out the judicial outcome of the Supreme Court of Bangladesh with the use of previous cases. So if we see the proposed workflow diagram, we used the collected data set and pre-processed in, and after that we extracted the feature using TF, IDF and word embedding. We test, train and split the data set. We implemented classifier and evaluation score and performance analysis. If we move towards the result and analysis part of our paper, that we can see that we have used GBC, SVM and XGBoost classifier in our paper. So as I said earlier, we have used feature extraction to do as TF, IDF and word embedding, and we have compare each of these is using accuracy, F1 score, recall and precision. So if we see the result of TF IDF, accuracy is 0.87, F1 score is 0.85, recall 0.83 and precision is 0.83. And the word embedding came 0.89, F1 score 89, recall 0.86, precision and so on. And SVM and XGBoost got the different type of result. So if we compare all of them, we can see that the result of SVM got the highest accuracy, and also the word embedding feature extraction did work really well. But here the best extractor was TF IDF, as we can see. If we moving forward the conclusion, in this research we have emphasized the subject of legal judgment prediction and employed topographical learning framework to solve several subtasks of verdict projection. So as in the context of Bangladesh judicial system, legal case result prediction has not gotten much consideration in machine learning and natural language processing application. For the Supreme Court of Bangladesh, we have methodically investigated the problem of anticipated outcomes. Almost every conceivable kind has been thoroughly investigated, and we reported the findings of several methodologies in comparison for many cases. Future steps in approach including following. So the future step we can take, that we can use different type of classifiers to update our models, and we shall be using different source of data. We can include different types of source as our judicial prediction as well. Here we only use Supreme Court's judicial result, but we can use different law judicial prediction as well. We have included the reference as the bibliography here. If we can see, In related work, the citation was the most. So if we move towards the reference, here is all of the reference in the bibliotext.
Hello everyone, I'm Ananya. So I'll be explaining the introduction and the related works part. Language of the law must be considered broadly in this context to include both written and spoken words, legal writings, judgments, and regulatory texts like decrees, rules, contracts, and obligations. The goal of this thesis is to investigate techniques for anticipating legal entities and judgments in court cases documents using legal NLP. Studying how pre-trained models can be adjusted for the legal domain and how this can impact performance on subsequent tasks in an environment with little unstructured data is the another goal. So here we have chosen 7 papers, and in the first paper the name of the paper is How Does NLP Benefit Legal Systems? A Summary of Legal Artificial Intelligence. They demonstrated the task from the viewpoint of NLP academics and legal experts, and they displayed various illustrative applications in legal NLP to investigate potential future approaches, conducted and offer a thorough review of the benefits and the drawbacks of the work that has already been done. Then, in the second paper, the author tried to raise awareness of the problems and difficulties with legal NLP to provide recent findings in this area, and more broadly to demonstrate how various analytical techniques are organized for this specialized language. Then the creators of the third paper of given reference conducted an extensive analysis of the traits of legal and unlawful material in the darknet, constructing it with content from a clearnet website as a result, as a control. Then in the fourth paper, author Robert Dale examined the application of NLP in the field of legal technology. According to his analysis, there are 5 sectors of legal practice where NLP is becoming more prevalent. Then in the sixth paper, researcher Mark S. Krauss used 4 kinds of convolutional neural networks and trained them into a dataset of 300,000 decisions. And as per this paper 6, the author stated the advantage of human processing are overcoming by automatic legal document processing, which will be highly beneficial to the average person for a better grasp of legal subject. So finally, they go over some potential future research avenues for the processing and analysis of legal documents. So thank you everyone, that was my part, and other will be explaining by my other group members.
I am Shandar Kumar Sen, and my ID is 1301101, and I will talk about the overall step-by-step process for this research project on how we came out the result of our project. So I will talk about the data pre-processing. Once we collected the data set, we need pre-processing tools to prepare it for the analysis, like removing unnecessary words, stuffs, and so on. So at first we tokenize the text of the legal judgments, which involves breaking the text down into individual words or phrases. Then we remove some step words, which are common words that do not add meaning to the overall data set and oftentimes can be ignored. And then we lemmatized the text, which actually means converting the verbs into their base form and removing prepositions and so on. Then we also remove punctuation and normalizing cases. The dataset we have used, the Supreme Court database contains properties like name of places, context, alibi, and date and time. So we had to manually remove them from the dataset as it does not actually contain any meaningful properties. Now, for the methodology part, we have actually converted the methodology into several parts. The first part one being the dataset collection. So, like every other NLP dataset, we also need to collect the data set from our local, not local actually, it is our Supreme Court data set. So it is actually called the Supreme Court Online Bulletin. The dataset is in the High Court division, and it is open for all, and can public can use it for further resources and so on. So we identified the source of the legal judgments, and we gathered as much as information from it. And you can see here that these are the paragraphs and summary of the cases. So we need to manually use it as a unsupervised data. Then we had used other tools like TF, IDF to convert it as a supervised data. Now, for the feature extraction, which is one of the most critical tasks of our project, we know that the cases listed in Supreme Court bulletin was written in a paragraph or text, and in order to make it more sensible for our NLP algorithm, we have to use several tools like TF, IDF, and word embeddings. So we extracted relevant features from the text of the legal judgments in order to represent them in a way that can be used in machine learning algorithm. This involved uh, technologies such as term frequency, inverse document frequency, and word embeddings to represent the text as numerical vectors. To complete, then we extract the features from the preprocessed text using that method. So now I'll talk about the term frequency inverse document frequency method, which we use to extract the data from the data set. So term frequency inverse document frequency is a method used to weigh the importance of words in a document or a corpus. It is often used to information retrieval and natural language processing tasks. So here are the process of calculating TF idea. So at first we found the number of documents in the corpus, as we mentioned the paragraphs as various documents, and this is referred to as the document frequency, or N. Then in each document or each paragraph, we evaluated the frequency of each term, which is also called as word in that document. So this is referred as the term frequency, or TF. Then for each term in the corpus or the document, we determined the number of documents in which it appears. This is referred to the inverse document frequency, or IDF. Then we calculated the TF IDF score for each term in each document by multiplying the TF and IDF scores. Then we normalize the TF IDF scores by dividing each score by the maximum TF IDF score in that document. This is known as normalized term frequency inverse document frequency, or TF IDF. Now we have also used topological learning before our model training data. So after the features have been extracted, we analyzed the structure of the data and identified patterns, relationship that may be relevant to legal judgment prediction using the topological learning. This involved technologies like graph-based analysis and network analysis. So in the model training method, we used various supervised learning algorithms, and we use these features to predict legal judgments. Then, like we have used GPC, SVN, and XGBoost as the machine learning algorithm to train and test data. And then we train the data set after applying TF IDF so that we could get more accurate data. We evaluated the performance of trained model using appropriate metrics such as accuracy, precision, F1 score, and recall. We repeated the steps to get scores for other machine learning methods, as we have mentioned in the first process, like GPC, SVN, and XGBoost. And we did not change much on the parameters level, as we wanted to keep things fair for other machine learning models.